also have standard form or scientific notation. Now you use standard form, right, or scientific notation to represent extremely small or very small or very large numbers, right? As a matter of fact, you can use them to represent numbers of any size, but it's more appropriately used to represent extremely small and extremely large numbers. Okay, it means that if you have a number like 6 million, this can be written in standard form. Okay, if you have, right, or let's say you have 0.00007895, right, this is a very or extremely small number, so you can represent that in standard form as well. Okay, and when you are representing numbers in standard form, there is a general format for that representation. Okay, so the general form: a multiplied by 10 to the power of n, where a is greater than or equal to 1 but less than 10. So a is a number that is greater than or equal to 1 but less than 10. So a could be anywhere from 1.0 right up to 9.999, right, and the 9 recurs. So a could be anywhere between 1.0 and 9.99999, but it cannot reach 10. Okay, n is a member of the set of integers. So this here means n is a member of the set of integers. Okay, both negative and positive integers, because n can be negative as well as it could be positive. So back to the numbers we have in the example up here. You would have to put a point 0 at the end here. You have to move the point in a direction such that you get a number that is within that range, greater than or equal to 1 but less than 10. So if we move the point one place to the right, we notice that the number would get larger. Okay, and 6 million, we want it to get smaller so that it could be greater than or equal to 1 but less than 10. So we want the number to get smaller. So since we want the number to get smaller, we have to move the point to the left. Okay, when you move the point to the left, the number becomes, as a matter of fact, anytime you move a decimal point to the left, numbers become smaller. If you move a decimal point to the right, numbers become larger. So we want the number to get smaller, so we have to move it to the left. If we move it one place to the left, the number becomes 600,000. 2 places to the left, it becomes 60,000. 3 places, it becomes 6,000. We want to make it smaller, so we move it another place, it becomes 600. Okay, if the point is here, the number would be 600. 1 more place, it becomes 60. That's still too large. We want it to be less than 10 but greater than or equal to 1. So we move it another place and we get 6. Okay, and 6 would be within that range. So in standard form, it would be 6. That would be a would be 6 times 10, and then we count the number of places we move the point. Okay, so we move it 1, 1, 2, 3, 4, 5, 6. We move it 6 places, so 6 times 10 to the 6. So that is 6 million in standard form or scientific notation. The next example we looked at was 0.000007895. Now this is an extremely small number, and to get it within the range greater than or equal to 1 but less than 10, we have to make the number larger, and we can only make the number larger if we move the point to the right. Okay, if we move it to the left, the number would get smaller. So we want to make it larger this time. So we're going to move the point to the right. So if we move it one place to the right, okay, it's still not large enough. We move it another place. Okay, so we continue to move it. As a matter of fact, we're going to move the point until we reach just to the right of the first non-zero digit. Anytime you're moving the point, you move it until you reach to the right of the first non-zero digit. Okay, so here the first non-zero digit, and in this case the only non-zero digit, is 6. So we move the point until we reach to the immediate right of the first non-zero digit. Here again we're moving following the point until we reach the immediate right of the first non-zero digit, which is 7. So our answer here would be 7.895 times 10. It's always times 10 because remember, times 10 is part of the general form for numbers written in standard form. So it's times 10, and since we move the point in the right direction, the power would be negative. Here we move the point to the left, so the power would be positive. The power has to be positive here so that when we multiply the 6 by that 10 to the power of 6, we will get back 6 million. Here the power has to be negative, so when we multiply 7.895 by 10 to the power of negative the number of places we move the point, so we move it 1, 2, 3, 4, 5, 6 places, so negative 6. Right, so when we multiply 7.895 by 10 to the power of negative 6, we should get back 0.00007895. So that is how you represent numbers or digits in standard form or scientific notation. And sometimes you may be asked to express it to a certain number of significant figures. So let's take the second one, 7.895 times 10 to the power of negative 6. Let's say we want to write that correct to 3 significant figures. Now, how many significant figures are here in the first place? Well, we have 1, 2, 3, 4 significant figures. We only want it correct to 3 significant figures. So we count 1, 2, 3, and after the third significant figure, we draw a line. We look at the fourth significant figure, it is 5, and since it's 5, we're gonna add 1 to the third significant figure, which is 9. So 9 plus 1 is 10. As a matter of fact, 7.89 plus that 1 under the 9 here would give us 7.90. So we get approximately equal to 7.90. Okay, and we have to put the 0 because 89 plus 1 is 90 times 10 to the power of negative 6. Okay, so when you are considering to write this type of numbers in significant figures, you don't consider the times 10 part. Okay, you only consider the part that represents A. That's the only part you're gonna round off to a certain number of significant figures or a certain number of decimal places, as the case may be. You do not round off the times 10 part. So these are the rules for significant figures and standard form, right, or scientific notation, right? The rules for significant figures, standard form, or scientific notation. Make sure you pause the video and try to learn them very well.